Hello everyone, welcome back to my channel. Let's start with today's topic. So, in last topic we studied about discriminant, and if discriminant is greater than 0, we are getting two real roots. If discriminant was equal to 0, we are getting two equal real roots, and if discriminant was less than 0, we were getting no real roots, right? But this was with respect to x-axis when y is equal to 0. But if we want to know the same thing with respect to a line, that the curve is getting roots with respect to the line or not, are they two real roots or two equal roots or no real roots? So how we'll get to know that? So what we'll do, this is the equation of line, this is the equation of curve. We'll substitute the equation of line in the equation of curve. So we'll get px plus q is equal to a1x square plus b1x plus c1, right? So I'll bring everything to the one side. We get a1x square plus b1 minus px plus c1 minus q is equal to 0. So from here we get, if we compare it with the general equation, ax square plus bx plus c is equal to 0, we get a is equal to a1, b is equal to b1 minus p, and c is equal to c1 minus q. So by these values of a1, b1 and c1, we'll check our value of discriminant, whether it is greater than 0. So we'll get two real roots, and the curve and the line intersect, and there are two intersecting points. If we are getting discriminant which is equal to 0, so we'll get only one root with respect to the line. That means, so we get only one intersecting point of the curve and the line. That means the line is a tangent to the curve, right? And if discriminant is less than 0, it means no real roots. It means the line and the curve are not intersecting each other, right? So no intersection. Here we have two intersecting points, right? So for finding two intersecting points when line and the curve are intersecting each other, so for verification we'll check whether the discriminant is greater than 0 or not. For checking whether the line and the curve are line is actually tangent to the curve or not, so we'll check whether discriminant is equal to 0 or not. And to check whether the line and the curve are not intersecting, we'll see that discriminant is less than 0 or not. I hope it is clear. Let's move forward. Let's try some questions. So, first question is, find the value of k for which the line y is equal to kx plus 1 is a tangent to the curve y is equal to x square minus 7x plus 2, right? So, this is the curve. Line is tangent to the curve. So, for tangent, we'll check for one point. It means we need to check that discriminant b square minus 4ac is equal to 0 or not, right? So, we need to find the value of k. We are given that the line is tangent to the curve. So with respect to this particular equation, we'll try and find the value of k. I hope it is clear. Let's try this. So we have y is equal to x square minus 7x plus 2 as the equation of the curve, and we are given y is equal to kx plus 1 as the equation of line. So I'll substitute this equation of line in equation of curve. So substituting equation 2 and equation 1, we get kx plus 1 is equal to x square minus 7x plus of 2. So from here we get x square minus 7 and minus k. So let's take negative common. So negative of 7 plus kx, and plus of 1 is equal to 0. So this is what we are getting. So if we compare it with the journal equation ax square plus bx plus of c is equal to 0, we get a is equal to 1, b is equal to negative 7 plus k, and c is equal to 1, right? For line to be the tangent of curve, the discriminant b square minus 4ac should be equal to 0. When discriminant is equal to 0, the intersecting point will be only 1. We will not get multiple intersecting points. So let's substitute the values of b, a, and c. So we get negative 7 plus of k whole square minus 4, a is 1, c is 1. So it is equal to 0. So whole square of 7 plus of k and minus of 4 is equal to 0. So if we open this whole square, we get 49 plus k square plus 14k minus 4 is equal to 0, right? So if we simplify it, k square plus 14k, and we get plus of 45 is equal to 0, right? So we can simplify it. We get k square plus 9k plus 5k plus 45 is equal to 0. So taking k common, k plus of 9, and taking 5 common, k plus of 9 is equal to 0. So k plus 9 and k plus 5 is equal to 0. So either we get k is equal to negative 9, or we get k is equal to negative of 5. I hope it is clear. Let's move forward. Find the value of k for which x-axis is a tangent to the curve y is equal to x square minus of k plus of 3x and plus of 3k plus of 4. Okay, so find the value of k, and the line given is x-axis. So x-axis is tangent. So it means x-axis is like this and curve is like this. Okay, and x-axis is a tangent to this curve. So we need to find that value of k. All right. So equation of curve is y is equal to x square minus of k plus of 3x plus of 3k plus of 4. Equation of x-axis is y is equal to 0. So if we substitute it, this is equation number 2, equation number 1. So substituting 2 in 1, we get x square minus of k plus of 3x plus of 3k plus of 4 is equal to 0. We compare it with journal equation ax square plus bx plus of c is equal to 0. We get a is equal to 1, b is equal to negative k plus of 3, and c is equal to 3k plus of 4, right? And we'll check for the discriminant. Because it's tangent, we get only one, we get two real roots, but those roots are not unique, they are same. So for that, the value of discriminant b square minus 4ac is equal to 0, right? When the line is tangent to the curve. So we'll find the value of k by substituting value of a, b, and c in this equation. So negative k plus of 3 whole square minus of 4 times a, that is 1, and c, that is 3k plus of 4 is equal to 0. So opening this whole square, k plus of 3 whole square minus of 12k minus of 16 is equal to 0. So from here we get k square plus 6k and plus of 9 minus 12k minus 16 is equal to 0. If we simplify it, we get k square and minus of 6k and minus of 7 is equal to 0. So if I try and find the factors of this equation, we get k square minus 7k and plus of k minus 7 is equal to 0. Taking k common, k minus of 7 and taking 1 common, k minus of 7 is equal to 0. K minus 7 and k plus of 1 is equal to 0. We get k is equal to 7 or k is equal to minus 1. So these are the two values of k that we can get. I hope it is clear. Let's move forward. Find the value of k for which the line x plus ky is equal to 12 is the tangent to the curve y is equal to 5 by x minus of 2. So the curve is y is equal to 5 by x minus of 2 and the line is x plus ky is equal to 12. So we can substitute the value of y from the equation number 1 into the equation number of 2. So from here we get, substituting 1 in 2, we get x plus k times 5 by x minus of 2 is equal to 12. So we get x times x minus of 2 plus 5k is equal to 12 times x minus of 2. We get x square minus 2x plus 5k minus 12x and plus of 24 is equal to 0. So we simplify it, we get x square minus of 14x plus of 5k plus 24 is equal to 0. So to get the line to be tangent, the discriminant of this equation should be equal to 0. So b square minus 4ac should be equal to 0. So we compare this with journal equation ax square plus bx plus c. We get a is equal to 1, b is equal to negative 14 and c is equal to 5k plus of 24. So we substitute the value, we get negative 14 square minus 4 times 1 and c is 5k plus of 24 is equal to 0. Let's simplify it, we get 196 and negative 20k negative of, so we get over here 96 is equal to 0. So we simplify it, we get 20k is equal to 100, k is equal to 5. So this is the value for k for which the given line will be tangent to the given curve. I hope it is clear. So I think that's enough for today. We'll continue with the next question in the next lecture. Thanks for joining. Bye.